Hey everyone, this is Bradley Bush. Today we're going to discuss logarithmic functions. If you've talked about logarithmic functions before, maybe it's been a little confusing because sometimes logarithms are a little confusing to students. But the good thing for you is that logarithms really are not scary. Logarithms are actually pretty straightforward. And when I say that, probably one thing that I could say that might help you be a little less stressed is that logarithms are just exponents. The output of a logarithm is an exponent. So if you're okay with exponents, then you're just one step away from being okay with logarithms. So big picture for us is that logarithms and exponentials are inverse functions. So you've probably talked about exponentials already. Oftentimes exponentials, exponentials are talked about just before you talk about logarithms because, as it turns out, exponentials and logarithms are inverse functions. So if you have an exponential function with a base b, then it has an inverse function that's a logarithmic function with also that same base b. One use that we have for logarithms is that we use them often to solve for the variables in the exponents in equations. And that's super useful. It's something that we do in algebra all the time. So if you have a variable in an exponent of an equation and you need to solve for that variable, then it's very likely that you can use or will use a logarithm to get that variable out of the exponent and solve for it. So let's talk about exactly what logarithmic function is. So here we have our definition of a logarithmic function. For any x bigger than 0, for any base bigger than 0 but not equal to 1, then these two equations right here are true. Log equals, or y equals log base b of x is equivalent to b to the y equals x. So let's kind of look at this a little bit further. First of all, let's note that this x value right here, that is an input to your function. And the b right here is a base. So if you remember bases from exponential functions, they are these things right here. The blue b, that's a base. And the purple y is an exponent. So this on the left here, in the red box, you'd see b to the y equals x. That is an exponential function that you could see. Its inverse function is a logarithmic function with the same base b, and the x and the y are switched. Most of the time when you're looking at a logarithmic equation, you will see something in this form right here. Y is your output. This is your output. And x is your input. And b is just your base, and that's given. So x and y will still be variables, just x and y, but b won't be b in an equation that's given to you. It could be 2, it could be anything, again, from up here in our definition, anything that's bigger than 0 but not equal to 1. And quickly, before we look at graphs of logarithmic functions, I just want to make a comment that you can see that y over here on the left is an output of the logarithmic function. Excuse me. If you look at the equivalent exponential form, where's that y? That same y is right here in the exponent as an input. And the x in the logarithmic form on the left, here is an input, and where is the x? On the right in the exponential form, that's the output. So the inputs and the outputs are switched between the two forms, but they're the same inputs and same outputs, the same variables. They represent the same variables. So let's look at the graph of a logarithmic function. I think most of you have seen the graph of an exponential function, which is right here in red. You guys have seen that graph before. Something that's notable, you probably learned that, let's actually take off that pink. You probably learned that all exponential functions of the form a to the x go through the point 0, 1. And this graph is no exception. We see a line y equals x, the green line in the middle here. And we also see the logarithmic, the inverse function, the logarithmic function that corresponds to the exponential function of 2 to the x. And that's graphed right here in blue. So let's talk about the exponential function, the domain of range, first of all. If our exponential function is 2 to the x, then what's the domain going to be? Well, it's going to be all real numbers. That R is, or that red is too fat. Sorry, I had to make it a little bit smaller. And what's the range? Well, we can see that we don't have anything down here in the negative y values. So we can, and we know from our previous study of exponentials that the range is going to be 0 to infinity. We also know that exponentials and logarithms, the exponential functions and logarithmic functions, they're inverse functions. So we know that their domain of ranges are shared, but they're switched. So if the domain of an exponential like 2 to the x is all real numbers, then the range of log base 2 of x is also going to be all real numbers. And the domain is going to be 0 to infinity. Thanks for watching.